Good morning, students. Let us start one important topic of production management, that is value engineering. Let us start with introduction of value engineering. Value engineering or value analysis is a methodology by which we try to find substitutes for a product or an operation. The concept of value engineering originated during the Second World War. It was developed by the General Electric Corporation (GEC). Value engineering has gained popularity due to its potential for gaining high returns on investments. This method is widely used in business re-engineering. The business re-engineering includes describe current process, create vision, value and objectives, redesign business processes and tools, evaluate concepts, plan for implementing the solution, implement the redesign, transit to continue process improvement, plan for implementing the solution. This method is widely used in government projects, in automakers, in transportation and distributions, in industrial equipments, in construction work, in assembly and machining process, in healthcare, and in environmental engineering, etc. Value engineering process calls for a deep study of product and the purpose for which it is used, such as the raw material used, the processes of transformations, the equipment needed, and many others. It also questions whether what is being used is the most appropriate and economical. This applies to all the aspects of the product. Simplification of processes reduces the cost of manufacturing. Every piece of material and the process should add value to the product so as to render the best performance. Thus, there is an opportunity at every stage of the manufacturing and delivering process to find alternatives which will increase the functionality or reduce cost in terms of material, process and time. Definition of value engineering. Value engineering comprises of a group of techniques aimed at systematic identification of unnecessary cost in a product or efficiently eliminating them without affecting its quality and efficiency. In unsymmetrical technique, it means the production of car having high production cost, low quality. In a systematic technique, in this case the production of cost is low and having best quality. Value can be defined as that combination of quality, efficiency, price and service which ensure the ultimate economy and satisfaction of the purchaser. Value analysis can be understood as a technique which helps everyone to determine this combination. Objectives of value engineering. Value engineering should not be taken as only price reduction technique, but instead it increases the value of product either by increasing its utility with the same cost or decreasing cost for same utility. Value engineering is the most effective management tool used for solving problems and achieving significant results. The objectives of value engineering may include: number 1, functional objectives; second is profit objectives; third is time concentration; fourth one is quality promotion; fifth one is standardization objectives; and last, indirect objectives. Let us start with functional objectives. Functional specifies the utility of the product, that is, what is the use of that product. There can be 3 main uses of that product. Number 1, primary; second one is secondary, and third is tertiary. For example, providing a packing for vacuum cleaner serves 3 purposes. This is vacuum cleaner. The primary purpose is to protect it from scratches, cracks, etc. Secondly, to make it recognizable to customer by the literature provided on it. Tertiary purpose is to impart a good appearance to it, which appeal to the customers. Hence, while performing value engineering on a product, it is necessary to maintain the functional objectives of an item to the desired level. Another is profit objectives. No doubt, cost reduction is the main objective of any engineering concern, but profit consideration not only aims at benefit to an organization, but also to a community or a country. Suppose we make a product in our country and it costs little more than that the imported product from the other country. If we take value engineering only and only cost reduction technique, then we can say that the imported product is more beneficial to us. But in reality, it is not, because in that case, though it is beneficial as person wise, but as country wise, there will be a great loss of foreign exchange. So, we would use and give performance to the product made in our country, but not to the imported one. Hence, value engineering can be applied for imported substitutions. Secondly, the overall cost of an end product may be reduced by obtaining raw materials or components at higher prices. If they reduces the manufacturing cost by a large margin, then the extra prices paid. For instance, a manufacturer who was using for the fabrication a particular welding rod for many years was persuaded to try another rod superior in quality and 15% higher in price. In the trial, it was found that the new rod was easier to work with, gave stronger welded joints, and made it possible to obtain more welded work to be completed in a given time. In actual practice, it was found that in spite of its higher price, the new rod give an overall net saving of about 10%. Next is time concentration. Value analysis also takes note of the time element of value. Also, an item may be of value only if it is available at a certain time, or by certain date and of no value at all arrives later. In many cases, it is also seen that a product is of short term use or a long term use. If a product is of short term use, then there is no use of costlier material to make the product. For example, a temporary X-ray laboratory. It was proposed to make a concrete wall as protective measure. A concrete wall is permanent structure item whose cost can be very high, and to use it for protection from temporary X-ray laboratory would be very imprudent. Ultimately, an earth mounted of twice the thickness was built around the laboratory to serve as a temporary protective wall at 1/10 the cost of the proposed concrete wall. Next is quality promotion. Value engineering also aims at solving quality problem. Repeated failure or rejection of a part invokes the analysis to be done on it. Reduced rejection result in increased productivity, better competitiveness, serviceability, and improved marketability. Providing a competitive and quality product helps in export promotion. Standardization objectives. Increasing globalization of the engineering industry has stressed upon the standardization of materials, manufacturing processes. Standardization can only be achieved by work simplification, process improvements, technology upgradation, and substitution of scarce and difficult source materials with easy available materials. All the above factors create a need for value analysis. Indirect objectives. Apart from the previous objectives, value engineering also aims at improved organizational efficiency, developing a logical and analytical approach to solving problems amongst the executives, nurturing and promoting creativity, encouraging a positive attitude, shedding mental blocks and negativism, promoting cooperation and teamwork amongst the executives from different disciplines, and generally developing cost consciousness and a value culture in the organization. Value engineering, therefore, while principally dealing with cost, take fully into account the entire situation from all points of view to give the best overall results. Value analysis procedure. Value analysis on any item starts with the identification of its function or end use, as the main purpose is to provide the required use value at the least cost. The question to be asked is what else will do the function at a lesser cost. As wide range of answers as possible should be obtained at each and every phase value analysis. In short value analysis, seek to obtain effective answers to the following 5 basic questions. What is the item? What functions does it perform? What does it cost? What else will do the same functions What will that cost? The value analysis procedure is divided into following phases to get systematic answers to the above questions. Number 1, oriented phase, then information phase, next one is function analysis phase, next is creative phase, evaluation phase, investigation phase, and last one is implementation phase. Let us start with orientation phase. This phase involves identification of the problems very clearly, selection of projects, formation of teams, or you can say formation of groups, laying down objectives and targets, and in depth training for all the team members. After clearly identifying what is to be accomplished, all the relevant information like drawing and technical specifications, this comes in information phase. The technical specification, performance, failure reports, quality, procurements, including whether produced in your undertaking or purchased from outside the production problem, etc. Next is function analysis phase, or you can say function, cost, worth analysis. This phase is the key to value engineering. It involves analysis and identification of functions. The functions can be classified into basic, primary, secondary, essential, and unnecessary functions. Not only function, but also comparison table of the function cost, function worth, value gap, and value index, etc. It is important to identify the function in its simplest and broadest form, so that as many likely alternatives as possible may come to one's mind later on. Functions are described by a verb and noun description as, for example, nut and bolt. This nut and bolt is used to fasten the parts. Here you can see clearly. Electric bulb, it gives light to us. Lock washer, it used to resist rotation. Next is creative phase. This is the essence of value engineering. All the possible alternatives are generated. This can be achieved by application of brainstorming and other creative techniques. In order to generate a large number of ideas for providing the functional requirements, free scope is given to every team members to express this exquisite imagination, innovation, even if they are not practical ones. To start with, the alternatives next is evaluation phase. The alternatives developed are analyzed fully now. The cost of each idea is estimated. Critical evaluation, this is evaluation chart. Critical evaluation of both good and bad points of any solution. The ideas which promise the greater saving are screened and shortlisted using techniques like feasibility, ranking, etc. Any likely objects are scarcely met to overcome or minimize them. Next is investigation or recommendation phase. Short-listed ideas are in depth investigated or to arrive at optimum and practical solution. A suggestion sheet may be issued to all the concerned for providing a final opportunity to consider the proposed changes, and after that the solution is recommended. Next is implementation phase. As a result of all the above phases, a definite, specific and tangible solution acceptable to all is reached. Now, the implementation is done for final verification, amendment of drawings, specification and releasing change note to design department, obtaining quotation, finalizing orders and stopping further procurement of replaced items for material department. Fixing data for changeover, releasing job order, work orders for production planning department, updating inspection plans and gauges for quality control department, amendments to product literature catalogs to dealers and customers through marketing department. Next is technique of value engineering. A person, Lawrence D. Miles, had done considerable work on this field. Hence, he is named as father of value analysis. He evolved a number of techniques which, on skillful application, helps to identify unnecessary cost, remove obstacles and provide a course of action for developing worthwhile value alternatives. These techniques are as under. Number 1, obtain all available cost. Number 2, evaluate function by comparison. Number 3, seek information from the best or most authentic source. Fourth one is work in specifics. Fifth, get all the facts. Next, discuss with specialists and take advantage of their ideas. Use standard parts wherever possible. Consult your supplier for new ideas. Think creativity, refine ideas, remove all the roadblocks. Get the maximum cooperation from your colleagues in other departments with whom you have to deal, and always ask yourself the question, would I spend my money this way? First, obtain all available cost. During the techniques, each types of cost taken as considerations, and those management decisions making costs are material cost, overhead cost, decision cost, prime cost, incremental cost, standard cost, labor cost, variable cost, fixed cost, shop cost, manufacturing cost, etc. Each of these costs may be of importance in different situations, but for the purposes of value analysis, those must meaningful for the purposes in view must be considered. Meaningful costs have the same relationship to good value as meaningful tests have to good performance. Next is evaluate function by comparison. During this technique, first we understand the main function of an item. Then we ask the question, what else will do the function at a lesser cost, and how do others perform the same function of an item, and what is their cost. It leads to a number of alternatives which can be examined, compared and tested to see if any of them is likely to result in cheaper but reliable alternatives. For example, a clamp bar made of 1.5 section steel 2-inch long have 2.5-inch threaded hole. Several thousand of these are required each year, and so little reductions in its cost would result in appreciable saving. First of all, let us take the function of a clamp. The basic function of this is to perform the function of 2.5-inch nut. It also performs the secondary function of eliminating the use of spanner to tighten the nut, as there is no space to insert a spanner for this purpose. The total function of the clamp bar is thus identified as a holding function, such as could be performed by 2.5-inch nut, which should not become loose when the machine is in operation. This later part of the function could be obtained by welding the two nuts together, welding them to a common piece of metal, or pressing them into same sort of holder which would keep them together. The cost of total function thus amounts to the cost of 2.5-inch nut plus the cost of holding nut together. It may be found that pressing the two nut into two holes stamped in a piece of sheet steel of appropriate length and welding the nut in the stamping may serve the purpose. This was actually done, and the result was that the total cost per piece was reduced by 75%. Next is seek information from the best or the most authenticated source. For value analysis, information on any aspect of cost, material, labor, methods or process of manufacturing, finishing, packing etc. should be obtained from the most authentic source. This knowledge mostly taken from knowledge person, and it often based on old information, insufficient knowledge, pre-convicted ideas, existing procedure of long standing and so on. So, mostly mislead the analyst. So, we should as the way possible obtain this knowledge or information, verify to ensure that there are no mistakes. Next is works in specifics. In this technique, we have to make a work, it depends upon the main function of that item. We should also take their secondary function into account. With this knowledge, it will be easier to determine the right manufacturing process that will produce the item to perform reliably and at the lower cost. Next is get all the facts. In value analysis, guesswork or opinions given off hand by someone may create confusion. So, all possible information must be obtained systematically. One way of getting all the facts is to ask oneself the following questions about each item or each part of an item to analyze and get reliable answer to those relevant to one's analysis. Does it contribute value? Does it need all the specified features? Can a standard product be used? Can a usable part be made by cheaper method? Do materials reasonable labor, overhead and profit total up approximately to its cost? Is anyone buying it for less? Will another supplier provide it for less? how much would that cost? Considering the quantities required, has it been made on proper rulings? Is the cost proportionate to its utility? This question will help us in value engineering. Next is discuss with specialists and take advantage of their ideas. In